One of the analysis types available in Inspire is linear buckling analysis. So this is accessed under the Analyse tool. You can see there's a buckling modes extraction option where we can choose to extract a certain number of buckling modes. The idea behind buckling is that for a linear static load case, for loads that are applied, you're trying to determine a factor which says how many times that load case will cause the structure to buckle. So it's very well suited to shell structures. So here we've got a very simple column, a solid column at the moment. What we're going to do is use the patch tool to just delete the ends, and this will turn it into a shell structure. So now if we have a look at the column in the model browser, you can see now requires a thickness to be applied to it. So we'll apply a thickness of 3 millimeters, and so now we have essentially a very thin walled column that we can apply some loads to. To start with, we'll just constrain one end of the model. So let's pick the edges around this end, and that will just simply do fixed constraint. And then we'll load the other end of the model. We'll just again pick the edges. We want them in the Z direction. If I double click that load to edit it, if I click the Z again, you'll see it flips direction. It's quite a handy little method. And we'll apply that same to the other edges. Now we actually didn't want 1 Newton, we wanted something a bit bigger than that. Let's say we can pick the 4 forces there, type in 1000, and that will update all of them in one hit. So now you can see they're all at 1000 newtons. So we've got our linear static load case all ready to go. We can now go into the Analyze tool. We will automatically solve for the linear static load case happens, and we want the buckling loads to be applied to that static load case. So it's the combination of those linear loads plus a modal analysis will determine the buckling factor. So let's run that and look at the results. Now that the run's finished, we can load those buckling results, and in the Analysis Explorer we see we've got 2 load case results. We've got just our linear static case where the beam's been perfectly compressed, and we also get results for the buckling modes. So we can see this first mode here, the factor is 70, so that means that a load of 70 times what we applied will cause buckling, and this first mode is a side-to-side rocking. Next one is local buckling under the loads at the top there. Third one's another combination of those, buckling bending in the other direction. This is a panel mode, so the panels are actually buckling for these ones. So you can see it's once you've got your static load cases, very quick and easy to set up and run a buckling analysis.